Okay, we reviewed in class the other day, but here's a quick review video. What I want you to do is I'm going to give you problems, pause, you do them on your own, and then check with the video. Again, it's not going to do you any good if you just watch the video. So do the problems as if it's a test. No helps, no notes, no nothing. See how you do. And then watch the answers. And again, if you get them wrong, do them over and over again. Rewind, do it yourself until you get them right. So I'm going to pause right now. You do the same. Work these out, and then we'll chat. Okay, to add, you have to have common denominators. So I'm going to look at the 6 because you can't glue pizzas together. I need the same unit. So 6 is going to work for this guy. Could use 12, but 6 is the smallest. So I get 1 and 3, 6. And 3 and 5, 6. And then at this point, you can add slices with slices. So that would be 8, and the unit is 6. And then pizzas with pizzas. It takes 6 to make another pizza. So I can group them and have, 2 left over. If I have 8, so I'm going to make another pizza and then have 2 left over, which is same as 5 and a third. Divide by 2 to scale down. If you want, you could, once you get a common denominator, instead, you could do all slices. So if this pizza has 6, 7, 8, that's 9, 6. And then if this 3 pizzas, they all have 6, so that's 18, 19, 23. Add all your slices together. So let's see, what is that? 40, or sorry. Can't do mental math today. If I add 10, it'd be 33, so 32. 6. And so then I could, at this point, they're both even, so I could reduce that. So that would be 16 thirds. And then again, make pizzas out of that. 3 goes into 16, 5 times. And then I'd have 1 slice left over out of 3. So either way works. Subtraction, same idea. I'm going to get a common denominator here. It's 4, so I'm just going to double and double. So I get 3 and 2/4 minus 1 and 3/4. I can't take 3 away from 2, so I'm going to have to ungroup a pizza. All of the pizzas come in 4, so 5, 6. Slices with slices, subtract. Pizzas with pizzas, subtract. If you don't like that, the other option is to get your common denominator and then make them all into slices, so improper fractions. So 3 times 4, each of those, that'd be 12, 13, 14 fourths. And then this would be 4, 5, 6, 7. Fourths, subtract, you get 7 fourths. So again, how many times is 4 going to 7? Well, 1 time, and then I would have 3 left over, so 3/4. All right, so again, if you got those wrong, do them over and over again until you can get them right. All right, I'm going to give you a multiply and divide one in a second here. So I'm going to pause and put them up there, and then again, you try them, and then watch the video. All right, so try these on your own, pause the video, and again, I'll go over the answer key, but do them on your own first. No notes, no help, don't look at anything, just go with your gut. Check them and then redo. So I'm going to pause it, you do the same, work it out, and then we'll talk. Okay, I'm back. So with multiply and divide, you don't need a common denominator, but you do need improper fractions. So unless you want to do long division and unless you want to multiply a bunch of stuff. So 1 pizza with 10 would be 10 plus the 9 is 19 tenths. To divide, we multiply by the reciprocal, so 4 thirds. All right, now at this point, you can multiply straight across and reduce. Otherwise, you can simplify first. So let's see, these are both even. So 2 goes in there twice, 2 goes in there 5. I'm going to get, 38 fifteenths. 15 goes into 38, twice? So 15 goes into 38 2 times. And with the leftovers of 8, and my unit is 15. If you didn't reduce, you would have gotten, let's see, what would that have been? 38 and 38, 76 thirtieths, and then again, you'd have to reduce or simplify. Over here, if you do not want to do improper fractions, you don't have to, but you have to remember that it's like a 2-digit times a 1-digit. So you'd have to take this times this, and then add them up, get a common denominator, all that work. But if you do improper, 2 pizzas with 2 slices is 2, add the 1 is 5 halves. It's a lot less work if you do improper. Let's see, if you want to simplify first, 5 goes in there once, 5 goes in there twice. You can multiply it across and get 3/4, which doesn't regroup because it's smaller than 1. If you didn't do that, you get 15 over 20 if you went straight across, but then you'd have to divide by 5, so to simplify. All right, so again, do those over and over again till you can get them right, and we'll talk about Venn diagrams in just a second. Okay, so in a Venn diagram, I might ask some questions and give some numbers. So like, ask a bunch of people, how many have a brother or brothers? Say 10 people say yes. Do you have any sisters, or you only have sisters? Only have sisters. 5 people say yes. Do you have both brothers and sisters? So do you have both? And 3 say yes. And then there's a total of 40 people in my sample. And I'm going to ask you a question. How many only have brothers? And how many have neither brothers nor sisters? So they're only children. So make a Venn diagram, try to figure it out, and answer those questions. And I'll be back in a little bit. Okay, so let's look at this one. So how many have both is 3. So I know that there. Do you only have sisters? So the people that are only have sisters, they're not part of the both people. They are just the only have sisters people. If I said, do you have a sister, and it was 10 people, I'd have to subtract the 3 from the overlap. But I'm just saying, how many of you only have sisters? So the only sisters part are here. They don't overlap with the both. Now, the brothers do, though, because I say, how many of you have brothers? And it was 10. But see, that includes those people that are in the middle, because it doesn't say only brothers. It says brothers. So 10 minus 3 would mean 7. So the brothers circle has 3 in it. Sister circle has 8. And then it says, let's see, there's 40 people total. So what is that? 15 so far. So 40 minus 15 is what? 25. So how many people only have brothers? That would be 7. And then how many people have neither would be 25. All right, let's pause here and look at the next section. From this section, I would do the book homework, look at story problems with fractions. That would be a good thing to practice. We don't have enough time in this video, but work on the book homework dealing with fraction story problems. Okay, section 1.3, make sure you can do graphing. So read the vocab in the bold, so make sure you know things like, for example, 0, 0 is your origin, is the name we call that. These guys are called quadrants, and they're counterclockwise, because remember, things move up in math, so that's why. Make sure you know how to plot points. So if I give you A is 3, 2, make sure you know that you go over 3 first, and then up 2 to plot the ordered pair. If it's like 0, negative 2, you would go down 2, and it better be on the y-axis because the number's in the y-axis. So the main thing in this one is make sure you can know all the vocab, and then also like a variable, let's see, x-axis, y-axis, all that jazz, and then make sure you can plot points. Okay, section 1.4, the main ideas are nutritional labels, scaling, and then rates and ratios, and then percent. So like on a nutritional label, like on page 25 with the junior mints, if I ask you to find a percent of something, you know that you're going to divide. So you just got to divide dealing with the content. So if I say like, okay, how did they get the 12% for carbohydrates or something like that? So then you're going to look at 12% carbohydrates. And if you go across from there, they have the number for the junior mints as what? 35 grams. So then you're like, okay, so that's 35 grams of carbs. So I must divide by grams of carbs to get it in a percent. Well, you go down and look at the 2,000 calorie diet. How many carbs do you need? 300 grams of carbs. These cancel, so you divide those numbers, multiply by 100, and it should be close to 12%. And again, it might not be exact because of rounding. So make sure you can do the, this kind of thing. If I say that you want to get all your protein, and you're going to get all your protein from junior mints, how many packages would you have to eat? Well, one package is 2% of your protein, and you need 100% in a day. So you could just divide and say, well, I need 100%, and each time I eat a serving, I get 2%. And so basically you would have to eat 50 servings of junior mints. Probably not a good idea to get your daily amount. So again, I would do, on page 25, I would do that problem, and in the homework, I would do the Velveeta cheese problem. Make sure you're ready for the nutritional labels. All right, let's look at scaling next. I gotta let my dog out here quick, and I'll come right back. Okay, scaling is when, like, I don't know, say you make $10 in 30 minutes. You could scale it up by 2 and say you're gonna make, what, $20 in 60 minutes, or you could say you're gonna make $20 in 1 hour. You could also scale it down. So you could say, okay, I'm going to divide by 10, so $10 in 30 minutes. I'm going to divide by 10, scale it down. So that means I make what? $1 every, 3 minutes. So things like that. Make sure you can scale. Rates and ratios. So rates are easy. It should tell you what to do. So it could say something like, say I lost, I don't know, 20 pounds and I lost it in, say 5 months, and say it's going to ask me for how many pounds did I lose per month. And so it's really, if you read it, it should tell you what to do. So it says pounds, which is 20 pounds, and it says per, which means divide 5 months. So you divide, don't multiply by 100, you're not converting it to a percent, and you get what, 4 pounds per month. So rates should be nice. They tell you what to do. Ratios are going to be really nice if you kind of write it out or draw a picture or something like that. So I like the strip diagram, but you can kind of decide what you like. So say there are 3 laptops for every maybe 2 2 tablets, right, in a classroom. And so I could tell you how many laptops there are, and you have to figure out tablets. I could tell you the total. I could tell you lots of things. So I like the strip diagram. So if I have 3 of these and 2 of these, I could say, okay, well, if there are 15 laptops, how many tablets are there? So if there's 15 laptops and there's 3 strips, each one has to be worth 5. So that means there would have had to been 10 tablets. The other thing I could do with that is I could tell you the total. So I could say, okay, well, there were, 30 technology things total. And so 30 divided by 5 would be 6 strips. So then I could say, okay, there's 18 laptops and 12 tablets to make that happen. Now, if you don't like that, the other option then is to write like laptop, tablet. So that's one option. And then you could keep drawing that over and over again. So then if you're like, oh, there's 15 here, then you could say, oh, well, then there's 9 laptops and 6 tablets. And if you needed to get up to 30, you're just going to have to draw this 6 times. So then you're like, okay, well, I finally have 30. So then how many of those are tablets? How many of those are laptops? So drawing either the scenario over and over again to answer the question, or doing a strip diagram and giving each strip values, whichever one works for you is probably a good idea. And then percents, the main thing you need to know about percents is scaling, or like the nutritional labels. Like to get a percent, you always divide and multiply by 100, and your units have to match. So you might have, say, 10 grams of fat divided by 20 grams of fat. Your units cancel. You multiply by 100, and you get 50%. To use a percent, you would always multiply. So like say I want to take 22% of 500 people. So the question might say like 22% of the people at the school got sick. There were 500 people at the school. How many of them got sick, or something like that? So when you use a percent, you always multiply. So here I'm going to take 22% of the 500 people and use the percent to get an answer. So that's kind of the main ideas. 1.4 is pretty heavy on the test. So I would definitely do all of the, reread this section, do all the homework again, maybe look at the nutritional label. And then also one word I didn't put up here is proportions and proportional. So remember, if you can scale it up or down, we say things are proportional. So, but again, they have to be exact. So they might be close, like, you might get paid a certain salary for an hour, someone else might get paid something really close. So you might get like, say, $11 per 1 hour of work. Someone else might get $10.95 for 1 hour work. We would say these are not exactly proportional, but we'd say they're close to proportional, but they are not exact. If someone made 22 hours for 2 hours of work, then these two we would say are proportional, because if I double this and or divide this by 2, whatever, we get the same answer. So that's definitely proportional. All right, I'll make another video for the second half in a little bit.